Welcome to Tech Ed, and welcome to the talk this morning. We'll be talking about identity and access. I saw one of my colleagues this morning, and I said, well, I hope this talk, which is a little bit abstract, a little bit future-oriented, is going to be meaty enough for Tech Ed attendees. We have a very technical, practical crowd here. And he said, as long as you have strategy or vision in the title, you're okay. People know you're going to be talking about a little bit more fuzzy stuff. So I think I'm okay. My name is Mark Ryland. I'm a program manager in the Identity and Access team at Microsoft. We are in charge of Active Directory and a lot of associated technologies that you're familiar with, ADFS, WIF, some of the new directory capabilities of our cloud systems. For example, the directory capability that's at the heart of Office 365, which includes both authentication and federation elements, also a cloud database, that directory database behind the whole service, which contains all the tenant data. So when you set up your federation and sync with Office 365, you're using technology that our team builds as a cloud directory. That's not sort of generally available yet to you as, say, a programmer, but you can imagine that we want to get there and get there soon. So what are we going to be talking about today? I want to talk about essentially these kind of 5 areas, or this is my outline. Begin with industry trends, do a few scenarios with a character that we'll call Jeff, look at some of the key building blocks that we need, some of which we have, some of which we still need to build for these more advanced identity and access scenarios that we'll be talking about. We'll talk about social graphs, which we're all familiar with, but I'm going to introduce a concept, perhaps a new concept, called a persona graph. That is what any given individual, that manifests themselves in different ways digitally. We'll call those manifestations of an individual personas, and talk about how we could possibly begin to reason about those and write software and systems that can manifest personas and allow us to think about them and manage them in kind of a rational way. And then sort of the next steps section. I'll try to leave plenty of time at the end for Q&A, and that can also help tie us into the kind of the here and now and how we get there. So you're welcome to ask those type of questions, although I'll try to have that come up frequently in the talk as well. So I'm going to give you 3 industry trends. These are not new to you. They're all very familiar. We'll talk about consumerization of IT. We'll talk about cloud computing. We talk about that endlessly, as you may have noticed. Collaboration, the sort of 3 C's are big trends, at least especially as they affect identity and access. What are these trends? Well, obviously consumerization. There's a couple of elements here. One of the ones that we think about a lot, those of us in the IT world, is the whole device proliferation. There's a variety of new platforms. They must be secured and managed. So we have all kinds of new operating systems, hardware, form factors that are really taking off. And so people are accustomed to using this in their consumer lifestyle. They want to be able to use them in a more managed IT environment. And so there's a lot of challenges, as you know, involved in that. But this is it's inevitable. It's happening now, and will continue. So we have to advance and enhance our systems to be capable of dealing with this type of device proliferation, and build the standards and capabilities such that they can all play together in a well-managed and secure environment. Applications. Now, this is another dimension of consumerization. People are accustomed to using their Hotmail or their Gmail. They're accustomed to these sort of always-on, internet-available systems that at least they should normally always be on. Accessible from anywhere, accessible from any device. So as I've said, that kind of moves the bar upward in some ways, like ubiquitous availability. It also moves the bar sideways. That is the kind of model, self-service, maybe slightly lower expectations in terms of sort of high levels of functionality, but just kind of good enough functionality in exchange for some of these other capabilities. These are what people are experiencing on a daily basis when they are in their consumer persona, and when they come into a business environment, they don't want to lose that. They want to have something that's at least as good. So that's another reality that we're all dealing with. Another element of this, beyond those 2 dimensions, is the merging of these worlds. The IT world and the consumer world are no longer completely distinct or disjoint. We're seeing this all the time. People want to have these two worlds together, whether it's on a single device doing both personal and business things, whether it's using two kinds of, say, it's, joint authentication. So to access the system, I may have to authenticate with some kind of a personal identity that transcends my employment at a particular company, but also maybe use some kind of identity and access system that is company specific. And maybe we'll talk about this notion of composition of identities. That's also happening right now and will continue as a very strong trend. Of course, cloud computing, I won't go on and on about this. You hear about this all the time. I'll only say that when you look at the value proposition of cloud, especially large-scale public clouds, but also to a significant degree private clouds as well, if you can really drive the cost of computing down, public cloud estimates are on the order of an order of magnitude. So you can run a 100,000 server data center at 1/10 the cost of a 1,000 server data center on a per compute basis. That's pretty compelling. Those are really compelling numbers. There's a Microsoft white paper, if anybody's interested, you can find on the economics of public clouds. Now, you're not going to probably see an order of magnitude change in terms of private cloud, but we all know that there's big efficiencies to be gained from server consolidation, better management around virtualization, all the kinds of attributes, self-service that we can also envision in our private cloud environments. So there's huge efficiencies here. It's going to drive change. And I think a good way to think about this, and in a sense, people like us are maybe on the receiving end of this. There'll come a point when it's a risk analysis. You could say to your boss, the CEO, "Hey, there's more risk here. I don't have the control maybe that I once had," and he or she will say to you, "But it's too. The money's just. This is compelling. I'm willing to take those risks." So I think there'll be a lot of decisions made on that basis, and we as an industry have to be able to respond and not actually, in fact, to decrease the quality and security, but also recognize that there'll be changes in how we do business, and the cost differences will drive lots and lots of change. And of course, collaboration. This is a theme we're all familiar with, but we see this more and more, the need for tightly integrated supply chains, collaboration on an ad hoc basis rather than going through all kinds of legal agreements and setting up special VPN tunnels and so forth to get your sharing with another company. People want to be able to just quickly create shared environments for sharing documents, sharing something as simple as calendar sharing. As you create work teams, V teams, get your work done, move on. These kinds of collaboration scenarios, which are surprisingly easy in the consumer space, have been more challenging on the IT side because we want to still have our controls, we want to have our audits and so forth. We're going to have to solve that problem. We're going to have to be able to do both. Identity, I think has been obvious, but from what I've said so far, is really a key to all these challenges, and that's really what we're going to be talking about today. So I'm going to give you some scenarios now. We'll introduce our character, Jeff, married with a 13-year-old daughter. He works for one of our famous companies, Fabricam, and consults with companies like Contoso. Everybody knows the story behind these entities, right? Why they exist. Does everybody know why Microsoft always talks about Contoso and Fabricam? Raise your hand if you know why we always talk about these companies. Okay, a few people do. Well, I'll tell the rest of you. So when we used to create fictional company names, inevitably, there were real companies with those fictional names. So we actually took these names and trademarked them. They're our intellectual property, and we can use them freely without getting someone suing us for using their company name. So that's the reason they exist. Now, you're going to notice a strong consumer flavor to some of these scenarios, and I actually have a couple more I put in the back of the deck for if you want to download this afterwards. And that's very intentional. It's intentional because I think that's a very strong trend. It's because people are going to be more and more mixing business and personal lives. And we as system designers and architects have to come up with solutions to enable these scenarios. Because they're going to happen one way or the other, we need to do them in an intentional way. So here's my first scenario. You're at breakfast. You have set up your personal calendaring and business calendaring, which are essentially integrated. And you would say, look, I don't want to be bothered during breakfast by random emails coming in and alerting me or buzzing my phone. But you can set a filter on that. You can create essentially an access policy for yourself. And that can be part of the system that you administer personally, and can be integrated into the IT systems that you interact with. So your presence and availability are adjusted contextually by by access policies that you've written down or that you've done with a simple little GUI clicker application. However, you've said in your policy, look, if I get a critical message like first morning meeting changing time or location, that should get through the filter. So that can get through. And again, you notice here it's the blending of personal and business life. It's a very common theme throughout these scenarios. Another kind of good consumer-oriented identity scenario, the devices that you're working with understand who you are, and they understand a context about you, not just your pure in the pure security sense, but also profile information, things about like what your preferences are, and preferences like music, like even contextual information like what you were just listening to on another device. This can flow with you, and it can synchronize so that you have this continuity of experiences. So the example we're giving here, the car computer knows about your calendar. That gets synchronized. And the music that you're listening to will follow you, essentially roam with you as you move across devices. Of course, these are optional, but we want to be able to enable these things. And of course, the identities obviously are critical to this because the car could have multiple different drivers. So you have to have a way to disambiguate and essentially log in someone in an implicit way and have them use these devices. And of course, we'll talk more about shared context as well. So we go to our first business meeting, which is a construction site. Now we get into some more kind of classic IT type scenarios. So you want to be able to download some blueprints from your client's document store, which is accessible from any device. It's a cloud-based store. Now, when you go to connect to that application to download those documents, your device will present a set of device claims, and if those device claims are essentially, hey, I can prove that I'm Jeff, but this is not a trusted device, then the application or the environment may well challenge you for some additional security information, like a PIN or some other kind of challenge response or two-factor auth. And again, this makes sense because the Contoso administrators are understandably concerned that, yes, we have set up our system so that we trust the Fabricam employees to access certain document repositories, but we don't know anything about their devices. They might have malware on them, what have you, so they could be compromised. So we're going to add a little security to this environment in a kind of interactive way or with some kind of stronger auth. Now, another option would be that this device can also become part of an additional trust fabric. We're going to assume for the moment that I've already, sort of logically domain joined, if you will, this device to my Fabricam environment so that its policies are applied, it's vetted, it's an understood device, even though it's been brought in by one of my employees and I don't own it. But why can't more than one set of security authorities do that to a device at one time? You may say, well, what about conflicts of policies, blah, 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 and of course there'll be lots of challenges there, but I would postulate that even something simple as last writer wins is probably good enough for a lot of policy scenarios that will actually really increase security and yet enable us to have devices that are usable in different contexts. So you'll see a couple times references to this idea of a trust fabric, and that's specifically what I'm referring to, is a device that in some way has been associated with a security authority, and that security authority has some say in what in the behavior and the security policies and the health of that device. Applications now can be context aware, and they can, for example, add new capabilities. So the upload, the upload to Flickr button is there because it's a photo app. But recognizing that this user now has a different security context and different identity in this business identity, the applications can be context aware as well. And now I have an upload to this business site as well as Flickr or my photos that I'm taking. In this case, the photos are being taken for business purposes. So we go on to lunch. We have our, this is kind of more classic. I mean, people do this today, right? You have social applications that tell you where your friends are. The difference here, though, is we're beginning to discriminate between, for example, I can say, look, I love my job, but I don't really necessarily want to have lunch with my work colleagues. I want to have a little break. So the system can discriminate between, your basically different types of social networks, a business type of social network, a consumer type or personal type, and adjust your status and availability depending on your preferences to essentially advertise your presence for a lunch date. and discriminate between those different networks. Now, another interesting set of scenarios come with this idea of blended identities or composition of identities. So, for example, this is an example of a living room scenario. So you're watching TV. The TV knows who's in the room. We have that technology now with Kinect. Of course, I'm using that term metaphorically. It doesn't literally know you're in the room, but despite the claims of AI, we still aren't there yet. Software is able to make algorithmic decisions based on who's in the room. There's now intelligence in the system, and again, policies that have been authored, again, probably in some very simple way. You've got to make this so people can get their heads around it, not be too fancy and too complicated. But you ought to be able to tell the environment, the entertainment environment, hey, when the 14-year-old is in the room, or the 13-year-old, filter the content appropriately. Use the content ratings that are available in these various systems to make it so that the content is family friendly. And the system will do that for you. Again, this is the notion of composition because you literally have, 3 logins logically. You have 3 people present, 3 sets of preferences, 3 profiles, and you've got to do some kind of blending of those. Now, when Jeff is there just with his wife, then those content filters are lifted. There may still be some filters in place, but the ones that are related to the younger member of the family get lifted, and so there's a couple of new things that are available that would not be appropriate for someone younger than the adults in the room. This is an example of blending of identities, and again, I've given you a consumer version of this, but it's not easy, not difficult at all to imagine business versions of blending of identities and blending of preferences and profiles and context that takes into account the fact that there are multiple people involved in a scenario. So what are we doing here? We're trying to build these great user experiences on strong foundations that are anchored in identity and access technology. We have, we're going beyond just can I log into this application? Can I use a username and password to get access to this document? We're trying to elevate that to something that's richer so that users themselves become elements in this environment. A user is also a resource. Access policies are very context-rich. They can depend on the time of day. They can depend on privacy issues, so exposing only certain things to certain users, depending on, say, a social network relationship. Presence information, location, devices, all of these things become part of this access environment. As I mentioned, access control goes both ways. You have the traditional access to resources, but you also think of, hey, people are resources too. Users are resources, so they have access policies around them. We need, in this world, a modernized trust fabric that can work with lots of different device types, that can allow devices to be associated and secured and given some kind of token, if you will, that says, look, I've been vetted and I'm willing to accept policies from some security authority and apply those policies. And those get updated and refreshed and so forth. And you can, of course, remove yourself from that trust fabric. And this needs to be something that's very simple and that works with lots of different devices. The hard part about this will be the policy authoring and management. We all know this. It's hard, we're not anywhere close to this today, obviously, and yet we're talking about even setting a higher bar for what we can do with identity and access technology. So, of course, for this to really be valuable, it's got to be based on open technology, interoperable across different operating systems, networks, and platforms. Now, I said this is way out there, but it's not maybe as crazy as it sounds. A lot of the pieces we need to do these types of scenarios are there, or will be soon. So here are some of the pieces that are here now that would make this maybe not quite as much like science fiction as we may have thought. We have, for example, in the consumer scenario, we have face recognition and presence information in a Kinect system. Tremendous amount of rich data around social networks through something like Facebook. Business context, LinkedIn. We have lots of information about you if you're willing to share it and share it in a private and secure and trusted way. The systems could make all kinds of interesting decisions and make all kinds of interesting access and identity-related things based on these social networks that exist. Our company directories know a lot about our environment and about our colleagues. What about collaborating companies? We don't really have that very well now. We create shadow accounts, we provision special accounts and special OUs. But we know that this is a very key area to enhance collaboration, is to make it much easier for people to share profile and directory information in a secure and trusted way and in a filtered way, so that collaborators outside your organization will also be accessible from what we would classically call a directory service point of view. Some of the things we talked about, Netflix, for example, that these systems acquire a lot of knowledge about our behavior. Again, some of that can be a little scary, a little big brother, if you think about what's being collected and the possible aggregation thereof. On the other hand, we'll talk a little bit more in a minute, but there's ways of doing this that maintain some level of privacy and control, and that's going to be something that's very important as well. I mentioned earlier that we, in Office 365, we're in late phase of our beta test there, and we're about to we'll soon be releasing this system, and that has a cloud directory service. It has all the tenant information's there in a protected way. It allows collaboration across tenants in a very nice way. It also allows certain types of collaboration using consumer identities, so live IDs, for example, or other identities in the future. So the notion that there could be directories that have rich data that are available in kind of a ubiquitous basis and allow for sharing and collaboration, this is not science fiction, although we're still in the early stage. Some of the things you need here also are going to require a lot of standards work. For example, there's a lot of work going around OAuth, which is a way to do delegated access, so I can essentially permission an application, a service, to access data on my behalf, and do that in a controlled way so that it's not just handing them my username and password, the traditional way that we would allow applications to access our data. Not a very good solution. And with OAuth, you can provision an app, and you can actually permission it, and you can say what the application can do, and you can also, disable that access because it's an intentional step to enable delegated access. So delegated access is a super important element to all this, but there's a lot of other standards, kinds of things we'll need to make really interoperable systems, all the way from policy languages that work across lots of systems, ways of naming things that are interoperable, and of course the management and the authoring and management and the auditing elements of these, which don't necessarily need to be standardized in the sense that you could imagine elements of the parts of the system that are unique to a certain vendor, but other elements really have to be cross-vendor, because otherwise you can't get these rich sharing models. Now, end-to-end control end-to-end trust is a really important theme. As you know from Microsoft, we have our Trustworthy Computing group that really focuses on this. And a key element of that is to increase people's control. It's not that we're going to get rid of the fact that lots of systems have a lot of personal data about us, but we need to increase the ability of people to control that and in a reasonable way. The traditional trade-off between security, privacy, anonymity, those kinds of things can really be diminished by using new kinds of technologies. For example, you've probably heard Microsoft talk about UProve technology, which is a technology that allows the system to issue secure tokens that are not traceable and not linkable. So you can actually make proofs based on a certain security authority, and the relying party can cryptographically be certain that an authority has made an assertion that's provable, and yet they can't know anything about the identity or the details of anything about the identity details of the party who's presenting the proof. And I can come up 10 different days with 10 different tokens, and there's no way to link those tokens so that the relying party can't, for example, track my behavior, even though in each given transaction they can be sure that some security authority has vouched for who I am or what rights I have. So that unlinkability and the privacy elements of these new kinds of cryptographic techniques are a great example of how we can apply technology to help solve some of the problems that occur in these highly connected systems. So we want the advantages of connectivity, but we don't want to give up all privacy. So there's ways of doing that, and technology will help solve those problems. End-to-end trust is critical to build a thriving ecosystem. Of course, the internet is already thriving, but there are so many examples of problems, security problems, privacy leaks, and so forth. To really build a trusted framework is a super important element of continuing to progress this revolution. And identity systems play a key role in that. So these kind of scenarios I've pointed out, we call this sort of identity in 2020, so we're talking about kind of a 10-year time frame. Now let's talk about some of the building blocks that are needed to build systems like this. Some we have today. So the strong move that Microsoft and other vendors have made towards these kind of modern protocols around claims and federation, these are very important and very critical building blocks. The reason is because we'll talk a little bit more in detail about what claims and federation do for you, but the key aspect of these is that they're compositional. You can actually have multiple security authorities involved. You can transform security tokens in a kind of, again, a purposive way. And these are attributes that we could have added to traditional security systems, but it just didn't go that way. The way the industry went was to build new technologies, new protocols, which have these very helpful characteristics. That's one element that's there. Another element that's there is essentially, nearly always connected. So very, very commonly our systems are connected. And this idea of cloud services as just being there that we can access and get critical information from and have secure interactions with cloud services. Not fully there, but we can see we're on a path to that. And that's a critical element of some of the scenarios that we've been describing. What pieces are missing? Well, there's a bunch of pieces that are missing. So this idea of composition and blending of identity, we don't have that technology yet in a rich way. The idea that I can, for example, do an authentication dance that involves both a consumer and a business identity in order to access some critical data. Let me give you one example. Suppose you have an employee who manages the Facebook page for your company. Now, what are you going to do in that case? You have two choices. You can say, okay, well, you as a Facebook user, personal user, we're going to give you certain rights over that page. Or you can create a special account that's a company account. Neither of those solutions is really that great. And on the one hand, if it's supposed to be very personal, very interactive, you really want real identities of people to be associated with your online marketing behaviors. Just like blogging and other things, the personalities of the people are important. So you really don't want there to be sort of a generic, Joe manager who's running your Facebook page. On the other hand, you want to have control over that. It's a pretty critical piece of company data and company set of, the way you present your company to the world is who controls your Facebook page. So ideally, you really want to have some blending of security identities such that there really is a real person who has certain rights. And they're associated with that person, but on the other hand, they also have to prove that they have those rights based on some company policies. And if they change jobs or they're terminated from their employment or they quit, move on, whatever, you can turn those rights off without saying that the person's not a Facebook user anymore, having to switch user accounts. Those are just very simple examples of what I'm talking about. Many of these things around composition are really, really useful. And we've sort of made do without them, but once you begin to think about it, you realize that we need to solve these problems. Again, I'll mention, the idea of the policy management and, logically centralized, but probably actually distributed in order to get good performance from these systems. Authoring, management, auditing of policies is going to be a critical part of this. So let's drill in a little bit more on claims and federation. You've heard Microsoft give talks about claims quite a bit over the years. I'm going to talk at a little bit more abstract level to sort of try to motivate what the value of this type of technology is. These technologies really enable certain, they involve certain patterns that are very useful for the kinds of modern identity and access scenarios that we've been talking about. There's also kind of layering you might have noticed already, and that is that claims are just very generically useful. They don't really require federation. There's a kind of layering there. One doesn't require the other. It's very useful to just have generic properties on security tokens. You could think of claims as being sort of a generic property bag that's part of a security token or that is a security token. And that's very generally useful, independent of there being more than one security authority in the picture of an identity scenario. So you'll see that we'll make some moves in that direction to make claims a more general part of our environments. But the composition of security authorities, which is what federation is, the idea that authorities can have now relationships and be involved in a chained process of authentication or possibly authorization, that's another very generic and powerful capability. So for claims, we've essentially talked about them already. They're just the ability to have these attribute-based identity artifacts. The other thing that's interesting about claims is you can sort of think of them as being, talk about security tokens, you can sort of compile them, if you will, into different token types. And there's a proliferation of token types, for better or worse, although probably there'll only end up being a couple that were very predominant. Well, probably one will be SAML and the other will be what's called a SWAT token, which is essentially an OAuth token based on the JSON format. But there are other types that are out there, and including the traditional Kerberos tokens and other things, and the ability to map between these and translate will be important because we'll have lots of different systems over time that have to interoperate. The nice thing about claims is they're just a very simple primitive that you can then layer other types of models on. So RBAC, for example, which is the model that we're all mostly accustomed to and still makes a lot of sense because it's a mental model that helps people to think about their access environment, role-based access control. So that is very straightforward to build on a claims infrastructure. And again, claims are very useful in federation scenarios. That is, they're useful even when there's only one security authority involved. But if there's multiple security authorities involved, they're also useful because of this ability to be transformed. So an incoming claim from a security authority A, when viewed from the perspective of security authority B, can be altered, can be normalized or changed so that relying parties can get a set of claims that differs from the originating authority. In all these things, of course, semantic agreement is the hard part. We have syntactic agreement. It's not that. It's very straightforward, a very flexible technology. But agreeing in our systems, at our system level, what does administrator mean or what does author mean? Those are the hard problems. And there's work in those areas, and there's standards that exist for many of the basic property types, but that will continue to be an area where probably lots of vertical industry agreements will be made and so forth to enable the meaning of claims to be normalized across different infrastructures and environments. So the key patterns about federation I wanted to just bring out. Well, first of all, the idea of abstraction. So when you write a claims-aware application, you're essentially taking out from your application code a lot of the details involving with authentication and authorization to some extent. We can talk about that. And you're essentially saying, okay, there's a set of library routines that handle all that for me, and I get back a certain set of normalized capabilities that I then use. And that's a very powerful model. Now, you could say, well, I've got these Windows applications that don't know anything about authentication. It's true that if you're in a pure Windows environment with integrated authentication, you can have essentially security tokens flowing across networks and so forth. And that model is really powerful and really useful, and it will not go away. But it has certain limitations, and by moving to the claims model, you add a little bit more complexity to the programmer, the resource or server programmer, but you also create a lot more flexibility for other types of security systems to be involved in these multi-authority dances. Light binding is another important part of federation. So, for example, you can't log into the internet, right? You go to resources, and in the federated security model, you go to the relying party, you go to the resource and say, okay, I want to access this resource. And the resource owner, the server application, is what tells you, go here, I trust this authority, go there to get a security token. From there, you might go to other security authorities. There might be a dance that continues beyond that initial security token service that the relying party trusts. But the point is that you acquire and build security context dynamically as you access resources. You don't just log in and have all of the security context that you need. And that's essential for these large-scale interoperable systems. We've already talked about composition, the fact that there are trust chains, that you can do transformations. The challenge of composition is that it's difficult right now to discover authorities or to have the kind of, what's the equivalent of the global directory that allows you to find and understand and reason about the different trust chains. Those kinds of capabilities will come. But at least the core infrastructure and the concepts are there. And of course, we mentioned this already, attribute transformation. This is a very important capability because you can't rewrite every application when some new thing comes along in an environment, but you can, outside of the application, remap the attributes of a security token and enable the application to continue to get the attributes that it was written to accept, even though the outside world is changing. Now, here are some of the things we really we don't have, or at least we're still in the baby stages. Ubiquitous access to cloud services. We have to continue to build. I'm sorry, this is another thing we really do have. I haven't gotten to the hard problems yet. So we already have now a range of interconnected systems, lots of platform support. We no longer worry about, basically the problems we used to worry about, sort of moving bytes around and getting basic connectivity. That's all taken care of by the web, which has become, of course, the application platform. We have ways for both, browser-based and smart clients to do things in these environments. And the programming models we have are adequate. I mean, they'll still be evolving, but we have things like SOAP, and we have now this movement towards REST-based protocols, and we can debate all day which is better or worse, but the fact is they'll probably both be around for a long time because the richer, more complicated protocols that really help with when you have the tooling support, they're really, really easy to use, but there'll always be the desire for script programmers and simple things to be there, and that will remain. So we'll probably have these things existing for a long time, but they both have a common infrastructure based on HTTP and HTTPS. And so we have this basic connectivity, and this is what we need to build these advanced services. But we need to enhance them as well. So one example I've given several times is we really want to be able to have devices be in a trusting relationship with more than one security authority. We also, there's a long way to go in terms of sort of semi-connected online-offline scenarios. There's work going on in HTML5 and other places for things like that, but that's still, in its infancy. I'm having trouble with my mic here, sorry about that. I'll keep my hands up. Here's some of the things we need to build. We talked about this already. Compound identities. We want to be able to do composition in multiple dimensions. We can compose identities in terms of the principles. And there we can have user-device composition. So you can say, when Joe is on device A, that has a security meaning. And I can actually write access policies that differentiate between Joe on device A and Joe on device B. Because it's really the joint identity of the user and the device that often has significant implications from a security perspective. There's another kind of composition, which is what I'll call persona-persona. I've given the example of Facebook, where you really want to be able to compose someone's real personal individual identity with their corporate IT-managed identity and have the two, as a composition, be what's permissioned on certain types of resources. There's many examples we can give of that. I'll give you another one. People often have corporate data that's really personal. It may be maintained by the company, but it's not their tax ID or their home address. The IT department may have copies of that information, but it really belongs to the individual. And things like 401k plans or other types of sort of jointly owned information, they actually outlive the employment relationship. So you really want to be able to both create and identify and permission things based on a real identity of an individual as well as their corporate identity. And that kind of composition, what I'll call persona composition, is really, really important. And the third type of composition is when you have more than one user working together. You might want to be able to write an access policy that says, when this person and that person are doing something jointly, then certain things are possible. I mean, there's really obvious and simple examples of that having in the financial space. We already have controls like that where you say, look, two people have to sign this check before it's a valid check. And because of the limitations of our information technology systems, we traditionally haven't built things that way, but I think in the future, we can, once we recognize the value and the ability to create the sort of generic composition as one of the properties of an identity system. And of course, you can also talk about composition of profiles. We've already talked about context, calendars, preferences. These things really need to flow across different identities. We'll talk a little bit later about a notion I'll call identity atoms, that you can actually build up these personas based on discrete pieces of information, which are very, very common and tend to be part of lots of different personas. We'll get to that in a second. Social graphs we've talked about. This is a key aspect that will become very, very common and ubiquitous, I believe, in identity systems, we believe. Just take a really simple example. When you go to LinkedIn, and if you went to LinkedIn and you looked at my profile, it would say, well, he's a principal program manager at Microsoft. And you'd say, fine. But what if it said CEO at Microsoft? Well, that might raise a few eyebrows. But if I said I was CEO of some small company you never heard of, that wouldn't surprise you. But I could have made it up, right? There's nothing there that allows a user of LinkedIn to verify any of the claims that people make about themselves. Yet they're personal claims. It's a claim about me, and it transcends my employment with a particular employer. So how would you rationalize that? Well, it would be very, very useful if you could have employer-verified claims that are part of your LinkedIn profile. It would be interesting if you could see a little checkbox that says, yes, Microsoft agrees that so-and-so is a principal program manager at Microsoft. And that kind of relationship and permissioning is really, really useful. And of course, it's very useful to security systems. Already we're getting things like security challenges based on your social graph, like what's your sister's name or something like that. And this kind of linkage, increasing linkage will continue. Now, obviously, I mentioned this before, that we really need to work on privacy-enhancing technology here, because there's a certain risk that if you build these systems in such a rich way that they have all this information and knowledge about you, then there's obviously some problems with that from a privacy point of view. But there are ways, as I said, to build systems where you can make proofs that don't reveal data that you don't want revealed. And we need to work on systems that have both of these properties, that you can they're provable claims without necessarily a disclosure of information that you don't want disclosed, or limiting who can get access to certain types of data. We talked earlier about the fact that you have composition of profiles with parents and children. So we can even think about things like responsibility graphs, where a social graph actually becomes more rich in what it can express about the relationship between people. You can have responsibility graphs in corporate. We already have that. We already have the notion of, your directory has a notion of who your boss is, who reports to you, who you report to. And there's already systems that, for example, when it comes time for submitting an expense report, we automatically will get routed to your supervisor. So there's already notions of kind of responsibility relationships inside of our identity systems, but now we're talking about maybe making those more of a first-class element, something that you can reason about, something that you can program, something that you can write policies about. And I've mentioned again before this notion of access control, very general. It applies to all kinds of resources. And persona graphs are also very important. We all have lots of digital identities, right? We have our Gmail account, we have our Amazon, we have lots of accounts in an Active Directory in various places. All this stuff is there representing real individual human beings, but in a variety of ways digitally speaking. That's not going to go away. In fact, it'll probably proliferate. I mean, one of the notions people have had is, gee, wouldn't it be great if there was just one? There was like a one-to-one correspondence between me and my identity. But when you think about that for more than a couple seconds, you realize it doesn't really make that much sense. For one thing, right away, there's a bunch of privacy issues that are very obvious. The other thing is that people very naturally, and this is just true of naturally of human nature, that you really want to create kind of reasonable boundaries and segments in your life. You really want to have some things that are more private, other things are more public. And the way we do that now is by having different accounts and setting up the personas in a kind of manual way. But imagine the systems were able to actually allow you to do that, to keep some separation, but also do composition as well when that makes sense. That's the kind of notion that we're trying to get to here with the idea of a persona graph, which is where you take all these different digital identities you have, and you can compose them when you need to or want to. For example, for certain types of proofing, or for composition of personal and business, and so forth. These are the types of persona, the connection of personas and the ability to reason about them and write policies about them is very valuable in a future identity system. So I'm going to create a little scenario here for you. So this is kind of some of my identity atoms. Some of these are mostly fake, I think. Oh, there's a few of them are actually real. You have my Hotmail address now and my Gmail address. So this is just an example I want to give of how we have the same kind of identity-related data. It kind of appears over and over again in different types of systems. And I'm going to call these little boxes in the middle my identity atoms. And then I will show you different actual digital identities I have and how they tend to compose. So, for example, if you look at Microsoft and what it knows about me, first of all, I want to emphasize a point here. We tend to think of this as corporate data, that Microsoft has all this corporate IT managed data, blah, blah, blah about me. It's mostly my data. It's my home address. It's my tax ID. It's my bank account information for direct deposit. It's my. Most of the stuff maintained about me by my company is actually my data. But we don't think of it that way. We think of it because Microsoft has the legal right to flip a switch and delete all this data in their databases. We tend to think of it as Microsoft's data, but it really isn't. It's my data. I mean, the information is mine. Their copy may be theirs. So, but look at this stuff. You know, of all this stuff, bank accounts, federation data, payroll data, social security number, my business address, my home address. Actually, I didn't put home address in here. I should have. They definitely know my home address. My Active Directory data, my SID, for example. You know, Microsoft knows all this stuff about me, but really only a couple of these really in a real sense belong to Microsoft. I would say that the federation data, for example, does. Whoops, that one, I didn't edit this from another talk that I'd written. It's got a different person's name on there. And the Active Directory data, those things really are, you know, I can say that's Microsoft's information. If I didn't work for Microsoft, those pieces of data wouldn't exist. But all the rest of this stuff is really mine. And you could think of my digital identity with Microsoft as being composed of all these different little pieces of data, which are really mostly mine and partly Microsoft's. Now let's move on to another digital identity. So Fidelity. They also have some of this data. They have my 401k information. They have my personal email. They probably have my work email too. They have my home address. Microsoft should have had that as well. I made a little mistake. You can see where I'm going with this. I can go to Live. I can see Live knows my main email address with Live, which is a Hotmail address. It has a backup address for me at Gmail, so if I have to, you know, do some kind of account management. Happens to know my mobile phone number. I've decided to use that as another factor in my Live ID and a way to do things like account recovery. Google has a certain amount of this information. They know both my email addresses. Amazon knows a bunch of stuff. They know my shipping addresses, my home address, a couple of email addresses. They could know my bank account, right? Under some vendors, you do direct transfers from your checking account. So I think you get the idea here. I don't have to belabor this. The government knows a whole lot of this stuff. My credit union knows quite a bit of this as well. Tons and tons of overlapping information in all these different identities, digital identities that I have. And you could think of then as my personas, my digital personas are composed of these little chunks. You could even imagine that the chunks themselves could be, first of all, signed security tokens issued by someone who's the issuer is trustworthy. That would be very interesting. Imagine if I could prove what my home address was. That's pretty valuable. Right now I have to do that by using your credit card information, right? People all the time enter credit card information in order to prove some basic kind of identity, you know, especially like that you're a real person, and also what your home address is. But that could be done in other ways. It's technologically very straightforward to create signed tokens where an authority makes a claim about me and people trust that authority as having the right to say that. So, and you could even imagine that you could have these little atoms in databases and essentially there would be a master copy, right? So that if I update my home address somewhere, it gets updated in other places. That would be nice. Now, you may not want to do that. Again, we have to talk about privacy and whether you can do that in a way that's acceptable. But clearly we're already giving away a lot of our privacy by just entering our home address in 1,000 different places, right? So if we're going to do that, it might actually make sense to allow one source of that information, which is then the authoritative source that other players with our permission can use. One last identity item, my federation partners for Microsoft can get at some of this data. Notice that something like, when you do federation, you can get a UUID to identify a user, because when you come a federated authentication, you want to be able to create a profile of that user and so forth. But in the more sophisticated federation systems, those UUIDs, those unique identifiers, are per partner, because you don't want correlation. So for example, if you use LiveID, LiveID will issue a UUID to relying parties, but it issues a different one for every user to every different relying party, because it's trying to maintain privacy and not allow correlation of different relying parties using the same unique identifier for the same individual. Now we get to kind of the more of the sort of ultimate goal of identity systems, and really that is really rich access control. That's what we all really want. That's the purpose of identity systems. I mean, yes, they have other purposes, profile storage, and so forth and so on, but really the core purpose for most of us, especially those of us in the IT world, is we have resources, and we have users, and we want to control what users can do. We want to have the right set of controls and policies in place. So this is really the goal of identity systems, generally speaking, or at least one of the key goals. Claims and federation help a lot in modernizing this infrastructure, allowing different authorities to participate, allowing collaboration scenarios, and so forth. But they also do something which I wanted to highlight and maybe make a claim, and you guys, folks, can argue with me if you disagree. But I would argue that the advent of these claims and federation scenarios and collaboration scenarios really are going to change the center of gravity from access from the identity side to the resource side. The reason being that to this point, the way that we typically manage access is by users and groups. Like we have a user account, they're in a set of groups, and the groups are then, or the roles are what the applications then reason about, and so the access control is based on roles or groups. And that's all fine when there's one authority and one sort of centralized control. And the paradigm of the past has been that the resource side, the application side, is very diffuse and very non-centralized. And the identity side is very centralized. It's usually in a directory service, and we can sort of reason about it. And that's a lot of our access policies have been focusing on the identity side of this duality, which is identities here, resources here. But I would argue that's shifting, and we really need to focus more on the resource side as the identity side becomes more diffuse and more decentralized. So I'm going to make a couple of more claims on that. So this is my argument, or my picture of this shifting of center of gravity. So on the identity side, we have the basic notion of a person or an entity. Usually that's always some relative to some authority, right? That's what your digital identity is. Some authority is asserting that you are you, or that a piece of software is a piece of software. We're using the notion principle, of course, very generally here. And on the identity side, we have things like groups and roles. We have lots of other attributes. We have application identity. We should be able to compose that as well. You should be able to reason in your software about the fact that it's Joe using application foo, not just Joe. We have device attributes and identities on the identity side. That's also very important. But other things come into the identity side, like location. Where is this person coming from? Where are they inside, a certain network boundary or not? Those kinds of questions arise. And there's other context that generally can be very useful on the identity side. We have on the other side, we have resources. We have, again, resources themselves often have security identities. So like a service, for example, runs in a security context. Then on the resource side, we have notions of data sensitivity, which sometimes are called labels or classifications. We have the requested operation, which comes over from the user saying, I want to say, for example, read or call method Y on object Z. The location of the resource is also an important attribute on the resource side, and there's other context there as well. I'm in a special case for the moment, the idea of the actual information that flows from the resource. When I make a request, so the model I'm using here is the user makes a request, and then the information flows back. And it's really the combination of this that allows us to create an access control and management system, including both authentication, which is essentially bootstrapping these identities, and adding claims which enable good authorization decisions, and then on the authorization side, which is more the resource side, saying, does this person have the right to do this operation? And the backflow from this, of course, is the auditing, reporting and auditing, because we want to know what happened in a system that's built to manage control of access. And I'm essentially arguing that we have more maturity on the identity side of this diagram, and that that's enhanced by the claims and federation model because of the ability to do composition and so forth. But we're weak on the resource and app side, and that's what we call the Sea of ACLs problem, right? If you want to know, this is a classic question we get from an IT audience. In fact, you could stand up in the mic in a minute and beat me up on this, like, how do I know what resources my user has access to in my corporation? And the answer is, nobody knows. You kind of know, and I'm being a little cynical, but it's hard. It's a hard problem, and it's because we've dealt with this problem historically by sort of decentralizing everything on the resource side and not having the ability to know in a more centralized, logically centralized way. Of course, we can't build a system in which you call a central authority every time you need to make an access decision. That would be incredibly non-scalable. But you do want a system in which there's a logical flow, policies centrally authored and managed, flowing out to resources, maybe not in real time, that's okay. Decisions, access decisions made, audit logs created, and then a flow back to some central authority. And that's where we want to go. So really the holy grail I want to argue is information protection. I want to add that to the picture, because in the previous notions, I have my identity, I've got my resource. I make an operation request, and includes a bunch of information about the identity of the user and the device and so forth and so on. Now the resource makes a decision about access, hopefully with some kind of logically centralized policy which is able to make a quick local call to get to essentially a policy decision point, make that access decision, and that will then flow information back to the user. Now often we kind of stop there, but then you stop and think, well, wait a second. Isn't it really the information that's important here? I mean, I've put an ACL on my resource, but if that particular user is the only user, say, that has the right to see that, and I send that data back, now the data is in the wild. I have no control over that data. Ideally, I'd want to tie my information protection to my access policies on the resources themselves. So a real holy grail here would be to be able to author the server application in such a way that the information as it flows back to the client side is protected with the same policies, or at least a simplified but reasonably associated set of policies that were protected the resource itself. So I'm going to say that really what I want to do is I want to have a local protection model which is also enforcing the same policies that I had on the resource itself. Now obviously this is not, it's impossible to do this perfectly. There's always the so-called, everybody that knows DRM systems knows the analog hole, right? You know what an analog hole is? So I copy protect something, like music, for example, but they can always put a microphone up to the speaker and record it. So now the quality's worse, and so that's what digital DRM systems depend on, is quality degradation. But if you're talking about information protection, that may not be quite so reassuring. But that's just, this is life, folks. Nothing's perfect. So there's always going to be the guy with the digital camera snapping pictures of his screen, stealing information from your company. But still, if you could get to the point where the application and software and operating system cooperated to make it really, really hard for people to take data and do something else with it they're not entitled to do, that would be good. I think we'd all agree. So that's what I'm talking about, is we want to get to the place where the information as it flows around is protected in a way similar to what the original resource protection was. And we should have a logical extension of our authorization model in our information protection model. So you author the same policies. Now again, the operations might not be as rich. For example, you could have only read or read-write maybe the only operations that are locally enforced. There might be a much richer set of operation types on the server side. But you want to at least have, identities could be the same. You could have labels and classifications be the same, or again, a reasonable subset. And ideally, the server programming environment does this for you automatically, right? Why should you write code to do this? Because the semantics are in the model, and if the programming environments were done the right way, they could do local enforcement for you on a set of supported devices. Obviously, this is not going to work for every device in the world if it doesn't have the ability to run the code that's needed on the client. So, in sum, where do we stand today? We've made some significant progress. I've mentioned some of those areas. We have available, or nearly so, meaning within the next few months, things like our Active Directory family with ADFS, which enables you to use this more modern programming style with your Active Directory identity information, federation, and claims. We have cloud-based identity providers and security token services for both consumer and soon business users, namely Live IDs and Microsoft Online Identities. And I don't mean to say just Microsoft. I mean there's other identity providers. And for example, Microsoft Online Identities will federate with incoming identities from both ADFS on your on-premise identities, and in the near future, we'll have SAML-P support because we have our Live at EDU infrastructure and user base, which uses SAML. Most colleges and universities for their identity management. So we'll support that as for inbound. So there's lots of identity providers out there, but I'm giving you some examples of the ones that Microsoft is building and shipping. We just shipped this very useful, what I'll call identity pivot called Access Control Service 2.0, which allows you to go and create a security token service, accept incoming identities from Google and Yahoo, Live, and ADFS from corporate identities, take the incoming claims, transform them with rules, and then hand them to a relying party application so that now your application can get a normalized set of claims. So when you're building a cloud application, this ACS service is a really, really useful type of capability, and I encourage you to look at that for any type of cloud-based systems you're building. And SAML-P, something that there was once a big fight between the WS Star protocols and the SAML protocols. Anybody remember the fight between the Liberty Alliance and... Good, no one remembers. Well, we don't remember it either, so we're not fighting that war anymore. And historically, we didn't support some of the SAML protocols. That's kind of going away in the sense that they're going to be there. We don't have a problem with them. Sort of. If anybody's interested, we can talk afterwards. As sort of how that war came about. To the extent it made any sense, I can explain. But it's kind of died down now, and the fact is that these are kind of two similar, overlapping, competing technologies. But we're not fighting the fight anymore. So we're going to support whatever makes sense for customers. WS Trust, WS Fed on the one hand, the SAML protocols on the other hand. And one big thing that was done toward the end of the WS Trust standardization, which is very significant, was at least the WS Star community had the good sense to adopt the SAML token format for its security token format. So even across even though the different wire protocols are involved, they both share a common security token format, which is a nice thing from an interoperability perspective. Microsoft just shipped yesterday extensions to our Windows Identity Foundation that allow you to do SAML-P, both creating relying parties and accepting incoming claims. I believe it has support for being an IDP as well, but I'm not sure about that. But I can help you find the download. It was just announced yesterday. So that's happening. But what do we have to do in the future? I've already talked about a lot of things. We have to continue to enhance these technologies. The delegated access is a critical thing that's going on right now with the OAuth protocol. That probably needs to be generalized, and there'll be a profile of that works with SAML token types. The initial release will be based on these web type tokens instead of the SAML tokens. There's still work that needs to be done in terms of identity selection and agents. Those problems remain unsolved. Lots of things to do in the cloud identity and interop space. And really, industry patterns and practices for some of the more advanced capabilities I've been talking about. Things like identity composition. Things like access control policies and management. And the ideas of linking these identity graphs, social graphs, persona graphs, and building infrastructure that is able to reason about these things in a way that works across different platforms from different vendors. All of these will enable us to build much richer, more powerful identity systems in the future. So that's the end of my talk, and I would be happy to take questions. Yes, the slides will be downloadable. Probably, I think they already are, but I tweaked them this morning, so get the freshest version this afternoon. And I think that the talk is recorded as well. Any questions, comments, pushback, complaints? Happy to hear it. There's a bunch of, I'm sure you have in your I'll just say one more thing, that in your schedule, there's a lot more practical talks on these exact kinds of topics scattered throughout the week. So I encourage you to go to those sessions for more hands-on kinds of stuff. But I wanted to give you this overview and see if that helped. Yes? Yep. The question was, there's lots of new capabilities we're developing for the cloud systems. What about the on-premise systems? And the answer is, we believe symmetry is really important. You'll see some things maybe ship first in the cloud, but we see the hybrid, what we call the hybrid enterprise, is kind of the long term. So we will not orphan our on-prem technologies. It may appear that way if something ships first in the cloud and you're kicking your heels waiting for the on-prem release, which won't maybe be instantaneous, but definitely the model is symmetry is a very, very good thing that we want to maintain. So, comments, questions? Any more? Oh, I'm sorry. Yep.
So you mentioned the concept of a global directory.
Uh-huh.
You mentioned all the different things that have your identity, but you didn't pull off LinkedIn or Facebook into your circle.
Right.
So how do you see the possibility there that like Facebook or LinkedIn would become that eventual master identity in the internet?
Yeah, good question. I didn't use Facebook or LinkedIn in my little example of identity providers or people that have my digital identities. Do I see them as either as sort of de facto becoming key players in this? I think the answer is certainly yes. They will be key players in a future of identity systems. This is a classic network effects model, that their systems are most useful when there are lots and lots of people participating. But it's critical that they do that in an open way, and my hope would be that they would see their role as a kind of public good to some extent and allow an open access to some of the data. Otherwise, if they're closed systems, then despite their large volumes, there'll be eventually, I think, pushback, and people will find other solutions. So. Well, thank you very much for coming. I'll be here for a while if you have any questions afterwards. Thanks.